Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's easy level puzzle. And as always, take that easiness with a grain of salt because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Today's puzzle is called Combined Effort by James Sinclair, and here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit such that every row, column, and designated 9-cell region contains the digits 1 through 9 exactly once each. We have arrows, where the sum of the digits along an arrow is equal to the digit in the connected circle. So, for example, if you had, say, 3 and 4 here, this would have to be 7, because the digits along the arrow must add up to the digit that is in the connected circle. We also have double arrows, where the sum of the digits along the burgundy line is equal to the sum of the digits in the circles at both ends. So the sum of all of these 8 digits must equal the sum of these 2 digits here. And that's how double arrows work. And finally, we have digits in cells separated by a black dot have a 1:2 ratio. So for example, if this were, say, a 2 here, this would have to be 1 or 4 to maintain a 1:2 ratio between them, because there's a black dot between them. And finally, you can find more puzzles like this at artisanalsudoku.com. If you enjoyed this puzzle, Mr. Sinclair has a bunch of puzzles there that you can follow along with. Those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, the one that stands out to me first is this box 3, which has 3 pairs of digits in a 1:2 ratio. Now, every digit except 5, 7, and 9 can be next to a black crop key dot. So, the reason why is if you have 5, 7, and 9, you get 2.5, 3.5, 4.5. If you double 5, 7, or 9, you get 10, 14, and 18, none of which are digits. So, because these use up all the other digits possible, these have to be a 5, 7, 9 triplet here. That eliminates 5, 7, and 9 in the rest of the row. So this must be 1, 2, 3, 4, 6, and 8. This is obviously, well, we don't know. I don't know if it's obviously. Anyways, here, we have to have 5, 7, and 9 in some situation for these arrows here. What are the possibilities? Um, 9 obviously cannot be any of these digits on these arrows because 9 plus another digit is never going to add up to another digit, right? 9 plus 1, at minimum, always adds up to 10 or more. So 9 is guaranteed to be here. Where is 9 then in box 7? Can't be next to the black crop key dots, can't be here, so it has to be one of these 2 digits here. What are the possibilities now? So 9 cannot be any of these digits. 9 can't be here either. So that means the most these 2 digits can be is 8 and 8, which would sum up to 16. So these digits are all in the same box, and they all have to sum up to the same sum with these 2, and then with these extra digits here. So this is at minimum 1, 2, 3, 4. Because they're all in the same box, they have to all be unique. So that's 1, 2, 3, 4, which adds up to 10. Then these two are in the same box, so that's at minimum 1 and 2, which adds up to 3 at least. So this is 10 at least here, 3 at least here. If this were 1 and 1, that would mean this could not be 1 and 2 here, right? 1 would eliminate a possibility from there. 1 would eliminate a possibility for 1 there. So if this is 1 and 1, this would have to be 2 and 3 at minimum. But that's too large. We have 1, 2, 3. We can't have a 9 here. We can't have a 9 here because of the 5, 7, 9. So this is at maximum adding up to 16. Well, we have 10 guaranteed here. 1 and 1 here, that's 12. And then 5 here, that's 17. That's too large. So we cannot have 1 and 1 here, which means this has to be 1 and 2 at least. And 1, 2, 3, 4 is 10, plus 1 and 2, plus 1 and 2 is exactly 16. So this has to then be 8 and 8 here, guaranteed. Well, where is the 8 in box 1? It has to be along the arrow, so that means it must add up to 9. It has to add up to 9 here. And we know this is a 1, 2 pair. This is 1, 2. This is 1, 2. So this is 1, 2, 3, 4 to add up to 16. We have to have an 8 in one of these cells. 8 is only smaller than 9, so it has to be 8 with 1, guaranteed. And then the 7 has to be one of these two digits because the 5 has to add up to it here. So this is 7, 9 as a pair. This has to be 1 and 8 and 2 and 5 to add up to 7. So 1 and 8 adds up to 9, 2 and 5 add up to 7. That eliminates 1 and 2 in the rest of the box. This is 3, 4, 6 as a triplet. That eliminates 3, 4, 6 in the rest of the row. So this is 1, 2 as a pair. This is 7, 9 here. 7 can't be here. Where's the 7 in box 7? Can't be next to the black Kropke dots. Can't be here, so it must be here. And both 7 and 9 have to be there. So this is a 1, 2 pair here. These digits in a 1 to 2 ratio, the pairs have to be 1 and 2 next to each other, 8 and 4 next to each other, and 3 and 6 is always going to be the pair for that. Well, 1 and 2 can't be here because of the 1, 2 pair in the column. 1 and 2 can't be here because it would be blocking, it would eliminate all possibilities for this cell here. So this has to be 1 and 2 here. That leaves these as 3, 4, 6, and 8. 9 obviously can't be on the arrow. And we could have 3, 5 here adding up to 8, or 4, 5 here adding up to 9. We cannot have 7 here. So this is guaranteed to be 5. No 5 here, no 5 here, no 6 or 8 here. 8 eliminates 8 as a possibility here, so that's 9, which makes that 4 and 5 adding up to 9. 4 is in a 1 to 2 ratio with 8. That means this can't be 4 or 8. It's 3, 6 as a pair. 8 eliminates 8 as a possibility here. So this can't be 1 and 8 adding up to 9 here. It's 2 and 5 adding up to 7 here, which makes this 9 here. And this is 1 and 8. 2 and 5 eliminate 2 and 5 in the rest of the row, so no 2 here. That's 1, which makes that 2. Remaining digits of column 3 are 1 through 6. This is a sum of 2 unique digits, so it cannot be 1 or 2. Okay. We have to have an 8 somewhere in one of these black Kropke dots. And 8 is in a 1 to 2 ratio with 4. So, and we can't have 1 and 2 here. We can't have 1. So 8 and 4 have to be in 1 to 2 ratio. This can't be 1 or 2 because that would eliminate all possibilities for these cells. And it can't have 1 or 2 here because, again, that would eliminate all possibilities for this cell. So this can never have a 1, 2 pair, so the only other pair is 3 and 6. So this must be a 3, 4, 6, 8 quadruplet, which eliminates 3, 4, 6, and 8 in the rest of the box. That means this must be 5 here, which eliminates 5 here. No 1, 2, or 5 here. This cannot add up to 5. Sorry, it adds up to 5. It's either 1, 4, or 2, 3. Well, we cannot have this be 6, because if that were 6, this would be 3 and 4 as a pair, but that would eliminate all possibilities for this arrow here. So this can't be 6. One of these is guaranteed to be 6. We have a 1, 2 pair in column 6, which eliminates 1 and 2 in the rest of the column, so no 1, 2 there. What else do we have? This cannot be... we can't have a 1 or 2 here, so this is 3 at minimum here. This could be 1 through 6 at most, because 6 plus 3 adds up to 9 at most. So this is either 4, 5, 6, 7, or 9. No 7 here, because again, the 7, 9 pair in the row. Okay. Where is 9 in this box 4? Cannot be here because of 9 in the row. Can't be here because 9 in the column. Can't be here because it doesn't add up to another digit. So 9 has to be one of these two, which means this can't be 9. It's 7, which means this can't be 7. It's 9. Where is 7 then in column 2? It has to be here. Because it can't be, we already have 7s in the boxes here, and this can't add up to 5. Okay. Remaining digits in row 4, we have 1 through 6, but these can't be 1, 2, 3, or 4 because of the 1, 2, 3, 4 quadruplet in the box. So this must be 5, 6 as a pair. That leaves the remaining digits as 1 through 4. This can't be 1 or 2 because of the 1, 2 pair in the column. Cannot be 3 because of the 3, 6 pair in the column, so that's 4. That eliminates 4 in the rest of the row. This is guaranteed to have 1 out of 3 or 4. This is guaranteed to have 1 out of 3 or 4 in the box. That eliminates 3 and 4 in the rest of the box. So no 3. So we have a 1, 2, 3, 4, 6 quintuplet in box 4, which eliminates 1, 2, 3, 4, and 6 in the rest of the box. So this becomes a 5, 9 pair. That eliminates 5 and 9 in the rest of the column, so no 5 there. It's 2, which makes this 5. 2 eliminates 2 here, so it's 1. No 1 here, no 1 there. This can't be 1 and 4. This is 2 and 3, adding up to 5. Therefore, this can't be 3. It's 4 and 6. 4 and 6 eliminate 4 and 6 in the rest of the column, so no 4 here. It's 3. No 3s here. No 3s here. Therefore, since this can't be 3, this can't be 6 anymore. So where is the 6? Actually, 1 eliminates 1 here, so this is 8 and 1. 8 eliminates 8 here, so this is 3 and 4 as a pair, which eliminates 4 there, so that's 6 and 4 there. So no 4 here. Remaining digits... Remaining digits of column 7. We have no 1, 2, 3, 4, 6. So we have 5, 7, 8, and 9 remaining. No 9 here because of 9 in the box. No 5 here because of 5 in the box. No 7 or 9 here because of 7 or 9 in the row. Remaining digits of box 5 are 7, 8, and 9. No 8 here because of 8 in the column. 9 eliminates 9 here, so this is 7, which makes that 9. That eliminates 9 in the rest of the column. Okay. Remaining digits of row 1 We have 3, 6, 4, 9. Remaining digits of row 2. We have 3 and 6 with 5 and 7. Okay. Uh, Remaining digits of column 9. We have 3, 4, 5, 6, 8. No 4 here because of 4 in the box. No 5 here because of 5 in the row. Where is 9 in column 8? Cannot be here because of 9's in the boxes. Can't be here because of the double arrow. Can't be here because of 9 in the row. So 9 has to be there, which means this cannot be 9. So these add up to at most 7. So this can't be 8 here. No 6 or 5 here. So because this must be 4 and 3 at minimum. Sorry, at maximum. Remaining digits of row 7. We have 3, 4, 6, 7, 8, 9. No 8 here because of 8 in the column. And one of these two is a 9. Okay. Remaining digits of column 8. We have 1, 2, 3, 6, and 7. No 7 here because of 7 in the row. No 1, 2 here because of the 1, 2 pair in the box. Okay. Where is the 8 in row 9? Can't be here because it has to be part of the 4, 8 pair. Well, also because 8 in the column. We don't have space for 8 here because of 7 and 9 there. Cannot be here because of 8 in the column. Can't be on the arrow because it adds up to at most 7. So 8 in row 9 has to be one of those two, which eliminates the 8 in the rest of the box. So this can't be 8. This is 7. No 7 here. No 7 here. This becomes a 5, 8 pair there. Okay. What else do we have? Does that help anything else? I'm not sure. Where are 1 and 2 available in column 4? Can't be here because of the 1, 2 pair in the box. Can't be here because the 1, 2, 3, 4 quadruplet in the box. So can't be either of these. Can't be here because of the 1, 2 pair in the box. Can't be here because of in the row. Can't be here because of 1, 2 pair in the row. So the only places for 1 and 2 in column 4 are here and here. So we have a guaranteed 1 or 2 here and a guaranteed 1 or 2 here. We have a 1, 2 pair now in this box 8, which eliminates 1, 2 in the rest of the box. So no 1, 2 here. Therefore, at minimum, this must be 3 and 4, adding up to 7. And this is the 7 is the most that you can have here. So this minimum must be equal to the maximum here. So this is 3 and 4 adding up to 7. 3, 4 pair eliminates 3 and 4 in the rest of the row. So this can't be 3, it's 6. This can't be 6 anymore. No 3 or 4 here. It's 5 and 8 as a pair, which eliminates 5 and 8 in the rest of the box. 3, 4 eliminates 3 and 4 here. So this is 6, 8, and 9 here. We have a 3, 4 pair in column 6 also now, which eliminates 3 and 4 in the rest of the column, and a 1, 2, 3, 4 quadruplet in column 5, which eliminates 1, 2, 3, 4, 4 in the rest of column 5. So no 3 here, no 3, 4 here, no 3 here, no 3, 4 here. We now have a 6, 9 pair in box 2, which eliminates box 6 and 9 in the rest of the box. No 6 here, and row 6 and 9 eliminates 6 and 9 here. It's 3 and 6. 3 eliminates 3 here, so it's 4. That makes this a 5, 7 pair. 5, 7 eliminates 5 and 7 in the rest of the row. So no 5, 6, or 7 here. It's 3. 7 eliminates 7 here, so it's 9, which eliminates 9 there, so it's 6, which eliminates 6 here, so it's 5, which makes that 6. 6 eliminates 6 here, so it's 9 and 6. 6 eliminates 6 here, so this is 8, which is in a 1 to 2 ratio with 4. That makes us 3 and 6 there. 4 eliminates 4 here, so it's 3 and 4. This can't be 6 or 8 anymore, it's 9. Again, we cannot have 1, 2, remaining digits in box 8 are 5 and 8. Ugh. There we go. These two are opposite digits. Okay, so let's color things now. We're gonna make this yellow and this blue. Therefore, this must be yellow here, and that must be blue there. This can't be yellow, so that's blue, which makes this yellow there. So blue has to be here as the remaining digit, which makes this yellow. So blue can't be here. Blue can't be this cell. Blue can't be here. Where is blue in box 5? It must be here. So blue has to be 2. So blue is 2. Yellow is 1. 2 eliminates 2 here, so it's 3 and 2. 2 eliminates 2 here, so it's 1 and 2. 2 eliminates 2 here, so it's 3. No 2 or 3 here. No 3 here. This can't be 6 anymore. It's 1, 7 as a pair. 1 eliminates 1 here. So this is 7, which makes that 1. 7 eliminates 7 here, so it's 8 and 7. 8 eliminates 8 here, so it's 5 and 8. 5 eliminates 5 here, so it's 7 and 5. No more 1s and 2s here. 9 eliminates 9 here, so it's 5 and 9. 8 eliminates 8 here, so it's 5. No 5 or 8 here, it's 6. That means it can't be 5 or 6, it's 8. 8 eliminates 8 here, so it's 5 and 8. 6 eliminates 6 here, so it's 4 and 6. 4 eliminates 4 here, so it's 3 and 4. And 3 eliminates 3 here, so it's 4 and 3. And that's a solution. Fairly straightforward. The tricky part, I guess, was this portion, and basically starting to color that, and also the column 4. But obviously nothing that majorly difficult. Yeah, easy seems appropriate for this rating. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.